Okay, so we can do problems that involve power that are like three-step problems, and they're not very hard. But if you don't practice them, you're not going to do very well with them. So basically, we've got work, right? Notice that work is force times distance. Sometimes that force is that we're dragging something, right? And this really is what mu times the reaction force. But this is on the level, right? Sometimes that force is lifting something, right? And then once we get the work, we can do power is work divided by time, right? And these are the things we know. Power, which is watts, work in joules. Don't confuse the W that is work with the unit for power, right? Force, we can have distance, we can have time, mass, coefficient of friction, right? And it's a little bit like a Suvat problem, only it's different. So let's try some of these. Okay, so an 840 watt winch, that is my power, right? Can lift a 2,350 kilogram lamb over. So we are lifting. So we're going to use this formula for force, right? And our mass is 2,350 kilograms. 8.2 meters, that must be the height, right? That's the distance. So our distance is 8.2 meters. Okay, in what time? There we go. Okay, so since we're lifting, I think we start with this guy, right? So the force is going to be the force of gravity, right? So 2,350 times 9.81 is 2,350 times 9.81. I get 23,000. That's a heavy Land Rover, right? 23,053.5 newtons. And now we know the force, right? 23,053.5 newtons, right? Okay, let's see. Oh, we've got force and distance, right? Since we have force and distance, we can now use this guy, right? By the way, we're not going to use this one. Okay, so work is force times distance is 23,053.5 times 8.2. So I take the number in my calculator and go times 8.2. And I get, wow, that's a big number. So the work is 189,038.7 joules. That's how much work it is to lift this Land Rover up, right? So we're filling this in, right? And now we're going to use this to find the time, right? So it's an 840 watt winch. Power is work divided by time. Then time is work divided by power, right? So the time is going to be the last step, right? Time is going to be this work, the 189,038.7 divided by the power, which is 840 watts. And that's joules, right? I just like saying joules. Okay, so see, divided by 840. And I get that the time is 225 seconds. Ta-da. Yeah? Do you buy that? I hope that's right. Okay. So that's one example. Let's do one that has friction in it. Okay. So this is Gummy Bear, right? Okay, drags a 45.1 kilogram box, so 45.1 kilograms, right? Coefficient of friction is 0.34. We know because they're dragging that we're going to use this equation, and we won't use that one, right? A distance of 16 meters, that must be my distance. In 11.7 seconds, that must be my time. Okay. So the first thing I'm going to do is I'm going to find the force that I'm exerting, which is the force to drag, right? Really, that's mu times the reaction force. So my force is going to be, let's see, it's going to be 0.34 times 45.1 times 9.81. Let's do that. 0.34 times 45.1 times 9.81. I'm getting 150.426, et cetera, newtons. So that's my force, 150.426. Okay, now we've got force and distance, so we're going to find work. Work is force times distance. So work is 150 newtons, 0.426, right? times our distance is 16 meters. It's newtons. It's newtons. Times 16. That's 2,406.8 joules of work, right? So now we've got the work. Right, and now we want to find the power. Power will be work divided by time, right? So that's going to be 2,406.8 divided by 11.7 seconds. So divide by 11.7, and I get 205 watts. Wow, she's powerful. Watts. I guess we only have 2 sig figs, so we'd have to say about 210. Right? So again, just fill in what you know, decide whether you're lifting or dragging, and then just formula. They're going to go in all different orders. So sometimes you'll start with this guy, or maybe you'll do this one, or maybe do this one first. Okay? Good luck. Look at the examples. Definitely try to work them out. And yeah,